So today I'm going to talk about emotion predictions um, of sentiments during the COVID pandemic. And so in summary, the executive summary is that COVID pandemic created a major impact around the world, and government and businesses had unprecedented decisions to make, whether to close or reopen, and other policies affecting. All of this was based on the sentiment of how people felt. And so this paper is about present measuring the sentiment. So understanding the sentiment and the accompanying emotions has been the research of many papers, but ours is focused on measuring them through social media data. So we propose a novel way to capture sentiment and emotions using a chatbot that reduces inherent bias prior to in the prior analysis. So we reduce the bias by asking them questions which are meaningful, and I will show you some of those questions, and then we analyze the sentiment. So we devise an extraction layer based on top of deep learning techniques like BERT encoders. And this extraction layer helps in predicting the sentiment accurately using transformers. And then we compare various models with transformers and find out how they perform over the existing traditional ML methods. We find that newer deep learning methods are um, about 1 to 5% better than traditional machine learning techniques, especially predicting the emotions of sad, fearful, and angry. Furthermore, we showcase that leveraging the sentiment helps the cold start problem, which generally transfer learning techniques have. We fuel that cold start problem by looking at product sentiment and other sentiment data, and we achieve about 8% minus 8% closer performance when we fuel it with this other product sentiment data or other data that we have. So the problem is businesses and government alike, they like to know the collective sentiment, and our solution is meeting their needs by measuring the sentiment. And this might be applicable to other future pandemics, not just COVID, but this measurement or experiment happened during the COVID pandemic. Additionally, the sentiment needs to be detailed enough. Earlier studies were not detailed enough. We predict whether the sentiment was sad or angry or frustrated and so on. And we get to that, or just not a bi-modal prediction. We get to the detail. Um, so the contributions of this paper are how can businesses collect data during the pandemic. So we suggest social media channels. What constitutes sentiment and the range of emotions? So we measure variety of range of emotions. How does the sentiment model track against emotions against the relative performance of the various emotions? Which one is better? Whether sad is predicted better, or whether frustrated is predicted better, and so on. And finally, to fuel the or to circumvent the cold start problem, we look at product reviews and other data to fuel to do a transfer learning to get almost 90% of the previous performance. There has been a lot of prior work in this area, especially Corona Tracker 6, which has been a paper which analyzes these outbreaks. Secondly, sentiment analysis has been quite common in social media and microblogging websites, um, in papers 1, 2, 7, and 8. Twitter has been at the forefront of measuring such sentiment, and these have been pertaining to other outbreaks like typhoon, Ebola, floods, Zika, as in 9, 10, 11, 12 papers. And there we base our sentiment analysis based on Plutchik's 8 emotion model, and these models are quite detailed. Other than just positive or negative sentiment, we get to the detail. So the methodology has been to fine tune with 3 data sets for transfer learning. One is the original data set collected in the Twitter and other social media channels of 697 sentences. So we launched a chatbot, EmoBot, which collected the data 697 sentences over a period which is shown on the next slide. So this is one data set. The second data set is product sentiment data set collected from Kaggle, about 45,000 sentiments. This is used to do transfer learning. And the third one is when you mix the original 697 collected sentence with product sentiments, how does it perform? So one is the original data set, 2 is the transfer learning data set, and 3 is the combo data set. Our algorithm, the main step is to use BERT to analyze the sentiment, and we use BERT base as the for the pre-trained model, and we fine tune it with fast AI APIs. We do some fine tuning of the product review data set on top of this BERT model. Data collection. So we launched an EmoBot. This was designed an intelligent chatbot. It is collecting 7 to 8 questions and answers by chatting with various individuals on social media, and it's a diverse group of individuals. Our lack of bias comes with um, the presence of different kind of questions in the question set. So we engage this intelligent agent to collect and engage COVID perception. That's called an EmoBot. So here, and then once the data is collected from social media using the COVID EmoBot, we present it through some secured layer in the cloud. We analyze the chatbot data. We devise our emotion extraction layer, which is the BERT transformer, and we fuel it to a dashboard in the which is publicly available. So that is the design. The design is the EmoBot is designed in the cloud. Its links are propagated through social media channels. This is how we designed our experiment, especially through LinkedIn and Twitter and other social media channels. And then the data is collected, 697 sentences, and then this EmoBot data is then passed through emotional extraction layer, um, and a classifier is built on top of this layer, which includes BERT, random forest, logistic regression, and naive Bayes. So we try to compare BERT against random forest, logistic regression, and naive Bayes. These are the questions which the chatbot asks. How does your current situation make you feel? What are your biggest concerns? What views you have about the future? And some of these questions are intelligent enough to distinguish between and reduce bias. How do people make changes in the pandemic? What is your view on the industries? Tell what city, where do you work, and how do you expect things to return to normal? Well, these have been done in the past, but these are future looking as well, in the sense that same thing can be applied to the next pandemic that's out there. Labeling, we did crowdsource labeling of the ground to establish the ground truth data set. We asked about 20 plus Northeastern students to rank the data set based on a scale of 0 to 10. The ranking of this crowdsourced data set has been to categorize them as surprised, happy, excited, agreeing, and so on, and the negative ones as sad, frustrated, fearful, and angry. This is the data set. The EmoBot 697 sentences, product review 45128 sentences, and the dates have been between 2017 to 19. The EmoBot was launched in 2020, and then the combo data set. So out of which the analysis is that the sentiment from the BERT model, the sentiment is the sad, frustrated, and fearful was the most recorded sentiment. Happy was a little bit less, almost half of the previous measurements of sad, frustrated, and fearful, and then surprise was also there. And so most of the sentiment was negative. The transfer learning techniques that we applied was basically take the product model sentiment, take it, fine tune the BERT layer model, and then give this sentiment predictions. So this is the fine tuning model based on product sentiment to reduce the cold start problem. Here's the result. The EmoBot, when we perform the classifiers, the BERT classifier did well. If you see, excited, agreeing, sad was the best performance by BERT transformer. Random forest did great on positive sentiments, and 91.91 and 87.87 for surprised and happy. Performance, this is the model accuracy with ground truth data set. Fearful and angry was once again BERT transformers did well. Overall, BERT transformers did more better than the rest. Random forest came a close second. Logistic regression and naive Bayes were at the bottom. This is the classifier's performance. And this is how good the transfer learning techniques are. When there is no data, if you had to predict when there was no data at all for the next pandemic, with product retail data, you get about -8% performance inaccuracy, which means that even though you might not have a data to pre-train any transformer model, you can train it using the product retail data for sentiments, and this is at -8% or -7.63% performance, which is pretty good to start with to understand emotions happening during the next pandemic. And so that is the finding of the transfer learning technique. In conclusion, BERT transformers were one of the best performing models than other traditional models. Transfer learning techniques is -8% accurate, and this is super useful because this data is publicly available. Negative emotions are more closer in limits, while transfer learning from retail product data, which is another good finding. And as the pandemic progresses, as we add more measurements, the error can be reduced from -8 to -3%. Thank you. That's my presentation.